Hello, everyone. How's everyone feeling today? Those were some tremendous panel earlier, weren't there? Um, it's going to be a big shoe to follow. It's hard to follow that panel, but we have an amazing topic today, talking about safer bridges to a multi-chain future. So with a lot of events that happened this past 12, 18 months, I think there's going to be a lot of interesting topics to cover. Today we have Nico Arqueros from dcSpark and Palma Studios. We also have Ben-Ari, who's the founder of Applied Blockchain, and also Hugo Philion, who's the co-founder of Flare Networks. So we only have 40 minutes to cover an enormous topic today. And I'd like to start with an icebreaker question, which is maybe we can talk about a regular bridge that you've recently crossed that may sound interesting. So, Nico?
Yeah, sure. Hi, everyone. So my name is Nico. I'm one of the core contributors to the Milkomeda protocol. So I'm going to start explaining what is Milkomeda and how it relates to this specific bridge. So what we do in basic terms, we bring the capabilities to deploy
I'm sorry, what I meant is like a regular road bridge that you have crossed recently.
Road, like a...
Yeah, like a regular road bridge. Yeah.
Let's see. I crossed from the European side of Istanbul to the Asian side of Istanbul.
That's a beautiful bridge.
Yeah.
Cool. Adi?
Yeah, I'm based in London, so I cross a few different bridges in London. Our bridge is called London Bridge, which doesn't actually exist anymore. The bridge that people think is London Bridge is Tower Bridge.
That's right.
But yeah, those are the bridges I cross.
Cool.
I guess I'll say I moved here, which is not so much a physical bridge, but a cultural bridge. So.
All right. Let's start by level setting what a bridge is. A blockchain bridge, as defined by Ethereum, is blockchain bridge works just like the bridges we know in the physical world. Just as a physical world bridge connects two physical locations, a blockchain bridge connects two blockchain ecosystems. Bridges facilitate communications between blockchains through the transfer of information and assets. So I just want to level set that as a blockchain bridge. Huge headliner from @WooBlockchain on Twitter quoted BlockSec team said, since July of 2021, 11 cross-chain bridge attacks have occurred involving more than $2 billion. And according to Chainalysis, in August of 2022, this was right after a hack, attacks on bridges account for 69% of total funds stolen in 2022. So my question to the panel is, why do you think these hacks happen?
So there is this platform called Rekt, R-E-K-T, that shows some of this information about the latest hack. And something that you can see there is that most of these bridges, they didn't have an audit, which is incredible. You cannot be putting something into production if you don't have an audit. And furthermore, that's not even enough, doesn't cut it. You want to have multiple audits from multiple firms, and that only covers one part, because security is not just having really smart people checking it. They still can miss something. So that's why, for example, in our case, we also went further, and we are doing formal verification of our smart contracts. And even further, that's a good start, but you even need to go further, because then what are the security properties that you're trying to save? Is all the code on-chain, or is there also code off-chain? So also you need to do an audit about the code off-chain and be careful about how do you store private keys and other things. So it's very complicated. So not having an audit is a crazy way to go into production, and even then you need to worry about always be up to date. And the last thing that I would say is that usually you could say that complexity is the enemy of security. The more things that you add, the more complex it is, so it's the more difficult to audit. So usually you want to like get to product market fit and then don't modify the code anymore. And this is like something that usually startups don't do. They want to add more features, and you need to continue updating your audits every time that you are adding features because you could be introducing bugs that could end up in hacks.
So you're saying that security audits are not quite complete in some of the hacks that happen. Cool. Adi has his hands up.
I think the first generation of bridges are like off-chain, like centralized exchanges. Right? So you've basically got technology which isn't really blockchain, which is being centrally managed, and there wasn't much diligence. Right? So just like with centralized exchanges, people didn't really ask too many questions. They just needed a quick, easy solution. And these bridges popped up, and people used them, but they didn't really go into depth on the technical side, on the security. People didn't ask too many questions. And after these hacks started to happen, if you started to look what was inside, as we've started to see with some centralized exchanges, it's not a pretty sight, and it's not a big surprise. So I think it's part of maturing of the industry, that we have to mature the bridge infrastructure. Just like the blockchains themselves have been through cycles, I think we're going to get a next generation of bridges which are going to be what we call trustless bridges, which don't have the same type of vulnerabilities that some of these first generation bridges have.
Yeah, I think if you look at it, perhaps the most egregious one was like Ronin. That was an attack on the multi-sig itself. I think the structure of at least that generation of bridges leaves a lot to be desired. Like, they don't really think about risk. One of the things we think about is, at least at Flare, is we think about how do you manage these things? We'll come on to some of those risk questions later, especially when it comes to things like reorganization risk. I guess we're proposing a bridge structure that's a bit different. Existing bridges essentially allow all of the funds to move in essentially one time step. We think that's probably, at least given the current technical capabilities, probably ill-advised. We have a totally different structure that essentially, you can't get rid of code risk, right? You still have to create code, and you have to have best practices there, and maybe there's discussions to be had about how you should do it, when you should integrate the auditor in the actual development cycle. Should it really be just a couple of weeks at the end of the development cycle? Probably not. But then there's a question of like, how do you structure a bridge to minimize risk, and how do you abstract out essentially the risks inherent in bridging? And that's what we're trying to do.
Got it. So more like a centralized exchange, and then there's a little bit of exposure through like software development, life cycles that may require, closer, audits and some sort. So interesting that it becomes like a honeypot, right? So how do you think that, could be some of the ways that we can actually prevent these hacks even further than the ones that we already covered today?
Yeah. I think just like the blockchain itself, a blockchain like Algorand is secured through cryptography. Right? That's really, in particular, if you look at Algorand, that's really what gives it its strength. And I think that bridges are part of this infrastructure. And so the thing that will make the bridge more secure is end-to-end cryptography. Right? It's having those cryptographic guarantees about what's happened on one blockchain and having that verified on the other before the other blockchain gives you the tokens, or does whatever it is it's supposed to do. So I think that's for me, that's the only solution, because that's how blockchains work, and that's what makes them secure. And if you don't have that end-to-end, you've essentially got a middleman, which is what we've got with these first-generation bridges. And that middleman isn't secured through cryptography, just like centralized exchanges aren't. And so you don't have those security guarantees, and so there's a lot more risk.
So when you say like there's a middleman sort of exposure there, I think maybe just for the audience, these are sort of a set of trusted validators, some might call it, that would keep a set of keys on one end and then and the other end as well. So on both sides of the bridge, and if those keys are compromised, then the assets that were secured on one side of the bridge or the other would be then easily transferred out.
Yeah,
Is that
those
what you mean?
validators have that power. Now, of course, you can decentralize the validators further, just like you do with the blockchain itself. But I think the less power you give to those validators, to those bridge operators, the better, right? And the more you can have straight-through cryptography and validation that they can't interfere with, the more secure the solution.
Got it.
I mean, I generally agree with that. I'd say it's a very hard challenge. The way we think about it is we restrict what can flow across the bridge in a single time step, and we collateralize that. Essentially, that means that if there is malfeasance, if those entities that are operating the bridge do steal the funds or maybe even don't make the transaction, you get your money back and you get it back quickly. One of the advantages our approach has is if you're waiting for a blockchain to confirm your transaction that you're trying to bridge, and let's say you do want to handle reorganization risk, which is Vitalik's biggest issue with cross-chain bridging, then you need to wait an awfully long time. In this ecosystem, that's not highly desirable. Most bridging is yield chasing or trying to find essentially some opportunity somewhere. You want to be able to bridge very quickly. Having available collateral where someone else is essentially taking the risk of the bridging means that you can move very fast, but you're paying them essentially the insurance premium to cover your risks.
Maybe this is a good segue to what you mentioned earlier, and I think you might be hinting about Flare Networks, Flare Time Series Oracle. Not that?
No.
Okay. So what do you mean by the time involvements around
So
security?
if you're using a purely cryptographic method, right, it's maybe not relevant to, say, Algorand, which has certain very strong security guarantees. If you're using a purely cryptographic method, you have to wait many blocks. If you then want to be absolutely certain that you have very, very low probability of reorg of a chain, you may need to wait a day or several days. So if you're using a purely cryptographic method and you want to use that safely, then you do have to have a reasonable time lag. I'm not sure that's acceptable for the majority of consumer use cases over the long term. We think that there are ways to essentially take the risk of a chain reorganization and basically put that on someone else. They get paid for it.
Cool. Nico? Would there be anything you'd like to add to how do you prevent this further?
So personally, I don't know much about Flare Network and what they're implementing for the oracles. For bridges, something that's very important is that you always, I think a lot of people have only focused in the smart contracts, which is important because that has been the source of most of the hacks, but that's not the only thing. Usually you also need to pass messages from other blockchains to move assets. And even further, what is the trust assumptions that you have in one end of the blockchain? You are trusting that the other blockchain is not going to get hacked or something is going to happen. So there's so many trust assumptions. So I believe that there is not such a thing of trustless bridging, because even further, even if you, for example, to make it more spicy, you're trusting everything related to cryptography, but then you're trusting the implementation of that cryptography. So there is always a trust assumption. So you need to aim for perfection, but you're never going to get it.
Yeah, I mean, I guess to add to that, Algorand specifically has got this tool of state proofs, right, which was launched publicly in August.
Right.
And I think the purpose of that, and it's quite a unique innovation among blockchains. It's basically to allow you to prove something about the blockchain outside of it, right? By being able to validate its state, and it's perfect for bridging, because in the bridge, instead of having to have a network that's listening to different nodes and agreeing together and taking this set of listeners taking their word for it that this has happened on Algorand, you can now validate that cryptographically. And that means you could extend that to a blockchain like Ethereum and validate it there. So the bridge in the middle wouldn't need to do very much, right? So this is the solution, right? The solution is to extend the trust of the blockchain so that things can be verified outside. So state proofs give us a really good way, good stepping stone to doing that. If we're bridging to Ethereum in particular, validating those state proofs is still quite a heavy process. I know there's a lot of work and optimization being done by the Algorand team to improve that.
Right.
But right now, that's still pretty heavy. So that's why in London Bridge, in the bridge that we're building, we're using what's called a secure enclave, which runs a tested code, which is linked to the smart contracts, and that effectively extends the smart contracts. And we do all the validation there of the state proofs and also the other chain, and then we provide proof of that validation to the other blockchain. So the operator in the middle can't really interfere with the process. And we will eventually decentralize that as well, only so that we can't switch the service off. But there's no other way that we can, with the current design, interfere with the bridging process in a way that a normal bridge operator could. That's, I think, the way forward.
I think that's a really good segue to like all of you guys' involvements in the Web3 space, especially on bridges. And you mentioned London Bridge. Why not we continue with that that topic?
Yeah. I mean, we've got the bridge, of course, alongside other bridges that are being built for Algorand. We've taken the same technology and we're also using it for oracles now as well. So we've got a platform called Silent Data, which also uses these enclaves in a similar way to connect to Web 2 APIs and generate proof about data that's private data that's in those Web 2 APIs without seeing it, and then enabling that to be validated in the smart contracts on Algorand. So that's a different type of bridge. That's kind of like a data bridge to Web 2, but it's the same concept. It's being able to provide cryptographic proof so we can verify things without anyone in the middle being able to interfere.
Cool.
Yeah.
Hugo, you want to go next?
So Flare's not really about bridging. Bridging is an application of Flare. Flare's a blockchain that has two protocols. A time series oracle, so for essentially price data at the moment, but could be other things that move over time. And it has I suppose, a unique protocol, which we kind of think of as a consensus algorithm that allows Flare to come to consensus over the state of some other chain. Maybe even some Web 2 APIs. So I look forward to working with you. But that allows people to essentially build smart contracts that can get richer data than is currently available. So price data, sure, you have oracles. Not many of them are particularly decentralized. And then state data, it's fairly unique, at least the way we're doing it. So this lets you build smart contracts. One of the sets of things that we think that's very useful for is bridging, but there's probably quite a lot of other things.
Yeah. I'd also add bridging. I mean, it's a bit more complicated than people think. So there's obviously the messaging layer itself, which is that we need to build a trust between the two chains. So we only do something on the second chain when we're absolutely certain of what's happened on the first chain. Then there's moving tokens, and those could be fungible or non-fungible tokens. At Applied Blockchain, we also build applications, right? We build dApps and quite a few on Algorand as well. A lot of these applications, especially the NFT ones, they have custom functionality in the contracts, right? In the tokens. So if you're taking an NFT and the NFT has some royalty payments associated with it, when you're bridging that, you want to be able to bridge that functionality as well, right? NFTs are quite complex because they're quite custom. If you just treat every token as the same, which is how bridges work today, that's going to be a challenge, right? You're not going to get the same risk. You know, the artist isn't going to get paid on the second chain.
Right.
So there's quite a few problems to be solved beyond just the messaging layer itself, which is the first class of problem.
Right.
And I think to have a healthy ecosystem where bridging can really work, you need those things to be catered for as well.
Multiple types
Yep.
of assets, right?
Yeah.
Cool. Nico, would you like to talk about Milkomeda?
Yeah, sure. So just to give some context on how we are using bridging, So Milkomeda brings EVM capabilities to Algorand. So you can deploy any Ethereum smart contracts, and it's going to work in this layer 2 solution for Algorand. So when you have a layer 2 solution, you need to be able to move assets from the first layer to the second layer, and then you can interact in this virtual machine, which is the EVM. And eventually, maybe you also would like to bring them back. So there is a bridge between the layer 1 and the layer 2. We are not bridging with other ecosystems, and that's why for us, we sometimes can implement like some cooler stuff that take advantage of like some of the things from Algorand. So for example, the first one, we are implementing this thing called projective rollups, that we are going to be able to project information from the layer 1 to the layer 2 with like minimum trust assumptions. Also, another cool thing that we are implementing, which is related to like bridging of messages, because sometimes you don't want to necessarily bridge assets. You also maybe want to bridge like instructions to do something. So something that we are aiming to do, and it could be like really cool for Algorand, and because Algorand has instant finality, we actually can implement this. It feels like pretty good. So imagine that you deploy a dApp in this second layer. If you have this on Ethereum, first you will have to move tokens to the second layer. But wait a second. First, you need to add another network to your wallet in Ethereum. And then maybe you can actually move the assets to the second layer. Then you interact with that dApp. Maybe it's a DEX, so you do a swap with another token, and then you need to bring it back. And try to explain this to your mom or someone that's like more like normal person. It's going to be very confusing. So to be able to get to like wider adoption, we need to have better UX. And how can this look like in Algorand while we are working with Rapid smart contracts? So basically, you will have your normal wallet of Algorand, MyAlgo, or Pera that doesn't know anything about the layer 2, doesn't even know about EVM. And you will do a transaction, and behind the curtains, we are going to be able to move the assets, perform the action, and bring it back in a hopefully like very low trust assumption manner. And we are going to be using state proofs. And hopefully that is going to be for moving in one way. And then to bring it back, we are starting to work with vector commitments, which is part of like also the Ethereum roadmap. So we can do something similar to what Algorand brought with state proof, which is really, really cool. But to be able to create proof from something that's happening in the EVM and be able to validate it on Algorand.
Cool. There's a lot to unpack there, ladies and gentlemen. I definitely won't be able to explain that to my mom. So, there is one post recently, a rather controversial one by Vitalik. He posted on Reddit at the start of 2022. That was also right after another hack. He said, why the future will be multi-chain and not cross-chain. There are fundamental limits to the security of bridges that hop across multiple zones of sovereignty. And he linked it to a tweet, you know. So, I mean, there's a lot to unpack in that Reddit post. Yep. It was a while ago. What are you guys' thoughts and opinions?
I think he was, I mean, he spoke specifically about another layer 1, which maybe I shouldn't name here. But I think he was alluding to the fact that the blockchains themselves can suffer 51% attacks, right? Or slipped my mind now.
Reorg attacks.
Huh?
Reorg attacks.
Double spend attacks.
Yeah. So basically, they're not decentralized enough, and then the security gets undermined. And he kept giving the example of that happening to Ethereum in his post, but he was really talking about other chains. And I think he was talking about the relative security. So even if your bridge is secure, if one of the chains is undermined, then if you have a bridge that's got wrapped tokens, or locked tokens, locked assets on one side, and then wrapped assets being minted on the other, then there's a risk around either side if one of the chains gets compromised. That's what his post was about. And he said, he was basically alluding to the fact that rather than all the chains being linked together in this cross-chain heaven, nirvana, there would be groups of chains that have similar levels of security. Right? And I think that makes sense, right? If people are willing to accept lower levels of security through lower levels of decentralization, which some popular chains do, then that's their business. I would put Algorand very much in that category of blockchains with stronger decentralization fundamentals, right, and security fundamentals. So I wouldn't be worried about that from an Algorand perspective. I think that's what he was trying to say in his between the lines.
Right, and Hugo?
So, I mean, he's absolutely correct, of course. But,
He's Vitalik.
you know, I thought there was a second step missing, right? Which is like, so how do you deal with that? I think it's relatively, in some ways, straightforward to deal with, which is that essentially the risk of what he's describing diminishes over time. The more blocks you get, the less likely you are to get a reorg that happens, 500 blocks back. Right? And you may get reorg in the next 10 blocks, the next 20, whatever. The further it goes back, the less likely you are to have a reorg. We solve that with collateral.
Right.
It's very simple. Right?
I think he was talking about like the 51% attack, like because on a chain, let's say Alice sent Bob something on chain X, and then that chain X was 51% attacked. After, say, Bob sends from chain X to chain Y some token that's native to chain X but wrapped in chain Y. So the recipient on chain Y might think that they have a token, but if a 51% attack happens on chain X, then Bob didn't really have the token to send to begin with. So what happens then? So that was a very interesting way of him writing very cryptically.
This still exists even with if you have cryptographic proofs that something happened on a chain. Right. It's like you would still need to wait a very long time. It's a question of how you deal with to be certain that there's no potential for chain reorganization. So it's how you deal with it. How we want users want speed. They want to be able to bridge quickly. They don't want to wait 3 days for their token. Otherwise, we can go back to the old banking system. It's a question of how do you ameliorate that risk. Our approach is that you lay off that risk on someone that wants to take that risk. And that's to me, I think that seems sort of fairly logical.
One of the attacks in the list that you sent us before the event was the Ronin bridge.
Right, $600 million, by the way.
Yeah, and that was a Sybil attack. That was the word I was looking for. It was a 51% attack. So there, the network wasn't very decentralized. I think it was single figures.
Yep.
And an attacker through social attack managed to get the keys or to get control of more than half of the nodes in the Ronin network, and through that was able to carry out the attack. I think it's something that you need to... No, that's not your understanding?
No, that's not a civil attack.
No, okay.
It's
okay.
a key
Not a civil
compromise,
attack, but a majority, controlled the majority and was therefore able to influence the network.
It was a 5 of 9, I think.
Yep.
Yeah.
But that's a kind of example. It's a little bit what Vitalik was alluding to, that basically you can't, if you're bridging between two chains and one chain gets compromised in that way, then the bridged tokens are compromised. Yeah.
So at the end, this is like a reaffirmation from Vitalik, from what I understand, towards layer 2 solutions. For example, because he is speaking from the Ethereum perspective, and instead of being like, hey, for scalability, let's use this other chain or this other chain, he's more of no, let's build layer 2 solutions that are going to solve our own problems in our own chains, so we are not going to be dependent on the security properties of other chains. And this could be sometimes really, I think he's correct, because, for example, we have other ecosystems, for example, Cosmos, where you have the IBC bridge, but all the different chains on Cosmos, they have different security properties. They don't share the same set of validators. So when you have bridges that accept tokens from other chains, you are accepting also the risk. So they start creating a little bit of systemic risk. So that's why I also personally am super bullish in creating specific solutions for layer 2s. And that's why I really believe in what we are doing with Milkomeda. So instead of using other chains that have EVM capabilities, we can use the EVM that's deployed on top of Algorand, so we don't need to be trusting other chains. And furthermore, what we see for Milkomeda, we want to be the VMware for crypto, and particularly deploy other virtual machines on top of Algorand. So for example, if someone wants to use Move, this new programming language that came out from Facebook, you don't need to go to another blockchain. Like there's two that are like going to be, one that's already using Move, and another one that's going to come out. The idea is that you can use Move, but on top of Algorand. So you're not going to be trusting the security assumptions of these other chains.
That's cool. Maybe this is a good way to move towards closing statements. And I'll quote certain things that's either on the websites of the teams that you guys are with and whatnot, and then some questions after that. For Milkomeda, is this protocol that's designed to improve the blockchain interoperability by delivering Ethereum virtual machine or EVM capabilities to non-EVM blockchains like Cardano and Algorand. So with the recent launch of Milkomeda Algorand A1 rollup, there's also partnerships like Blueshift, Stellar, Multichain, and upcoming Brightside and XLR. Can you walk the audience through on what each of these partners mean and what they are to the multi-chain ecosystem?
Yeah, so I can take a step back and explain which also fits for Algorand. When you see an ecosystem, how can you categorize the apps that are like make this ecosystem grow? And one way to categorize this, you could be thinking about, we have in one bucket DeFi. In another bucket, we have NFTs. In another one, we have DAOs. In another one, gaming. So something, when you want to grow an ecosystem, you need like dApps in all of these buckets to actually grow. And some of them are going to be measured in different ways. So for example, for DeFi, usually the way that you measure is with TVL, total value log, how much money there is in the protocol. But for example, for gaming, it could be quite different. It could be like for like games or matches per day or like per hour. So sometimes I feel like people focus too much in TVL, but as we realize that blockchain is not just DeFi, we're going to start like understanding more that there's other ways to also bring value to the ecosystem. And to complement this, also that I have seen that if we look at DeFi crypto primitives, most of them, they have come out from Ethereum. And basically, in other chains, what we have been doing is basically reconstruct something that was working in Ethereum. Maybe we want to be using another programming language, but we are building it in another chain. So I think right now we need to start like in these other chains, like in Algorand, we need to start pushing for like newer stuff that maybe in Ethereum they're going to be trying to copy us. And that's the part that we are like trying to get there. And particularly for Milkomeda, what we see is decentralized gaming to be like one of the major use cases, which is different than what I call Web 2.5 gaming, which is basically a centralized game with NFTs. I don't think that gets it because it doesn't take advantage of the blockchain, and that's why we are pushing towards more like completely trustless gaming. And I think this could be like a use case that in Algorand could be pretty cool, and hopefully then it gets copied somewhere else, and that proves like that it was good.
Very much looking forward to the trustlessness of that. And for Adi, so the London Bridge is highly appealing initiative, to bridging between Ethereum and Algorand. On the londonbridge.io website, it spells out transfer tokens between Algorand and Ethereum using the additional security of state proofs and hardware enclaves, like you mentioned earlier. Recently, Algorand completed a launch of state proofs on mainnet. Can you help illustrate, like, this applied in conjunction with the hardware enclaves, which is a really interesting combination.
So the state proofs I alluded to earlier, they're obviously this innovation from Algorand to allow us to verify the state of Algorand outside of Algorand itself. And that's super useful for a bridge, right? Because obviously on the bridge you want to be able to check that a token's been locked before you go and mint it somewhere else, for example. So that's what the state proofs give us. Now, the state proofs, if you look at what Algorand have published and their vision for this and how bridges will use this, it's what we call a trustless bridge, where the blockchains themselves, smart contracts on each blockchain, are able to fully validate what's come from the other blockchain, right? And then you take out the operator in the middle and what they can do. All the operator in the middle is then doing is passing messages around, right? They can't actually interfere in them or change them. So that's really where we want to go with this. Now, we as a company at Applied Blockchain, apart from developing blockchain applications and TEAL, smart contract applications, and so on, we've specialized in different types of cryptography. So we've experimented with zero-knowledge proofs, multi-party computation, different types of advanced cryptography, and we landed with these secure enclaves. Specifically, we work with Intel SGX, and there's a few properties of these enclaves that we see that we find really useful in this type of scenario, and also for the oracles. Right? One is it's a hardware-secured environment where you can run code, and you can't see the code. So you can do privacy-preserving computation, and you can't interfere. The second thing is that the code is attested. Right? It's attested by the manufacturer, and they don't actually get to see it. So there is a third party there, but they're not active. Right? And they don't get to see what's going on. So they're very limited in what they can do. And together, that combination gives us this trust layer outside of the blockchain. It allows us to extend the trust of the blockchain. Now, not everybody likes secure enclaves. In the crypto world, some people will see it as still depending on the chip manufacturer for a level of security. So it's not that there's no controversy there. But for us, it's a great middle ground. The actual attack vectors are well documented, and you know, the whole, you know, all this space is full of different compromises and risks and so on. What we see, the advantages of using enclaves in this type of scenario far outweigh the disadvantages and the risks. And so we think it brings this ability to do things safely on the edge, between blockchains and between the blockchain and the outside world. And so that's why we've focused and built these two products, the bridge, London Bridge and Silent Data, to do that. Okay?
Hardware and software, best of both worlds. So Hugo, on Flare's website, it states there are two primary types of technology used within cross-chain bridges: custodial, including multi-signature schemes, and also the light client relays, and neither are satisfactory. So then it talks about, you know, introduces layer cake, which is really interesting. Can we dive deeper into what the claim meant in the quote?
Sure.
And how layer cake sort of solves it?
Yeah, so essentially multi-sig based bridges I think we've covered, you know, clearly centralized, possibly need to be regulated, essentially holding someone's funds. Other people have tried to decentralize by essentially using light client relays. We find that to be quite interesting, especially when combined with things like proof of stake, whereby essentially the bridge can then only really safely operate up to about a third of the value of the stake before the security guarantees over that become essentially fall away. As if you, let's say you wanted to transfer funds which were in excess of, say, 10x what the stake was on that chain, there's nothing there really securing, stopping the nodes from at least creating a kind of ransom attack where they stop the transaction by not serving the actual data and saying, well, now if you want to move this amount, you're going to have to pay us. And that's, you know, a fundamental limitation of the concept of proof of stake, which was never designed to be built around essentially cross-chain communications. It's self-referential. So with layer cake, we do a couple of things to try to mediate the risk. The first is we split up bridging events into a definable amount, which is secured by the underlying token itself, which we hold as collateral. The second is we protect against reorg for a certain amount of time, obviously not infinitely, again, by taking additional collateral. You pay for that, but it's not very high. Having that collateral available also means we can do some interesting things cross-chain when it's not being used. So for instance, that gets into things like cross-chain flash loans. You know, that's because we've got the collateral there. Show we've got the collateral there, so you can potentially then use that collateral, you know, at will across various different chains. That's sort of the idea. But that's just layer cake. That's just one, I guess, product that's being built on Flare. Flare is a blockchain more generally for essentially an EVM-powered blockchain that has essentially two sources of data, price and the state, to allow people to build, you know, many, many more products than just essentially the two bridges we've conceptualized.
Very cool. Thank you so much, to the panel. We have a few seconds left for questions. If there's anybody brave enough to raise their hands and come up to a microphone. Going once. There's a hand up back there. Maybe you can shout it out, or we'll repeat your question.
Hello? 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 Hello. So I'm Alan Settleman. Hello, everybody. Basically, I'm a member of GBA, Government Blockchain Association, and we develop a blockchain maturity model. I would like to know what do you think about this, and if you are considering to use this kind of models for the audits you, Nicolas, I think, was mentioning before.
I don't particularly know this maturity model that you're referring. I don't know if you guys know.
I'm not familiar either. Yeah.
No, I'm not familiar with it.
Yeah. Maybe,
Okay,
maybe you can
Maybe say a
reframe the
few words about
question.
it, yeah.
Yeah.
Well, there are many blockchains there outside and a lot of systems running, so people start believing about applications which are built on. For example, Algorand, it's a trustable infrastructure, but there are other infrastructures outside that maybe are not. How can the users outside be sure that the blockchains are not a risk? So it's a kind of new standard, so a standard, putting all the blockchains around the world in comparison to see if they are approved to run and not.
Yeah. I mean, I'd be interested to look at it in more detail. Obviously, the way blockchains, I guess as technologists, the way we think about the security of blockchains is through the actual implementation and technology. And so it's those security audits, it's the fact that these blockchains are out there in the wild and they're not protected by any firewalls or anything like that. They're battle tested. That's how we're looking at their maturity. But I think, one thing, we haven't spoken about what's just happened in the last few weeks. I guess it's not the topic of this talk. But for me, one of the big surprising things in this industry is that there isn't enough diligence, right? Especially on the technical side. So as techies, we can look at some of these protocols and some of these blockchains and just say, look, this looks risky, or we don't understand why there's so much activity here because we can see some issues. We don't see any of that in the press. We don't see enough diligence just in general, especially technical diligence, all around in the industry. So I don't know exactly what this standard is about, but if it does anything to address that, then it's probably welcome.
Thank you.
Cool. One more hand. I think that might be the last question we have time for.
Hi. Yeah. My question is about the new feature in the Algorand blockchain, that's the state proofs. We know that the bridge have a layer that is either centralized or decentralized, depending on how you verify the transactions across the bridge, right? But how do you think that state proofs can help you and eliminate that layer? Because that's where most of the vulnerabilities are arising. You have transaction, you lock that transaction on, let's suppose, Algorand, and you release the equivalent token on the Ethereum, but that has to be verified or validated by the centralized nodes or decentralized network in middle. So how the state proofs can actually help there and eliminate that centralization layer?
I'm not an expert in state proof. My CTO will know more. But for example, for state proof, you don't need a centralized middle like network. You can verify it on Ethereum. Right now, one of the issues is that the proof could be quite big. So I think the team is implementing some type of CK snark and also how to read the CK-SNAR will have to be a smart contract on Ethereum. But this is quite good because you can assure that something happened in Algorand without having to rely on any other information.
Yeah, I would just add to that the state proofs are just a proof, right? So the real security question is who's validating them and where, right? So if those proofs are being validated by the destination blockchain itself, by those smart contracts, then you have the guarantee in that smart contract before it does anything like minting a token. If those state proofs are being validated by a middleman, an operator, that's just running on a server, and they're just going and minting tokens on the other chain, then there's almost no point having the state proofs, because you're completely trusting that middleman that they say that they've checked the state proofs. So the state proofs in themselves on their own are not enough, right? It depends how they're being used.
Great. This is an amazing topic. Once again, please join me in a round of applause to Nico, Adi, and Hugo. Thank you, guys.
Thank you.